I'm a mother of a 1-year-old daughter who has had at least 6 ear infections in the last 6 months, which makes her actually one of potential candidates for ear tubes.
I took this clinical otolaryngology class at Mass Eye and Ear last year, where we actually looked inside each other's ears. And when people would look in my ear, they could see scar tissue from actually when I had ear tubes when I was 2 years old.
Tympanostomy tubes, also known as ear tubes, are devices that are placed frequently in children, but also in adults, under conditions of recurrent ear infections, and that is to evacuate fluid that's stuck behind the eardrum or to ventilate the ear in order to prevent recurrent infections from taking place. Current ear tubes, as we know them, are very much unchanged from when they were first introduced about 40 years ago and have had persistent problems.
Sometimes these ear tubes get clogged and administration of topical antibiotics do not make it into the middle ear. They can be prematurely extruded, they can be very invasive and cause perforation, scarring tissues and potentially hearing loss. Sometimes they have to be reinserted, which leads to more surgeries under general anesthesia, which are truly undesirable by patients and parents.
And I think that some advances within material science that have occurred over the last few years may be able to address these issues.
We're full of pipes in our bodies, and they are supposed to be friction-free. So nature has evolved already how to make piping non-adhesive to bacteria, non-adhesive to a whole range of other biological foulants.
Our team leverages unique biocompatible materials and designs, and we utilize an easy to manufacture route through silicone injection molding.
Not only that it makes the tubes non-adhesive to microbes, but it actually creates unique transport properties. In one direction, the tube is capable of releasing tension and otitis media coming off the inflamed area, and in the other direction, to have antibiotics, drugs that can be delivered to middle ear to treat the infections. That is a highly unique, customizable feature that has never been seen before.
So this can reduce otorrhea, and this can also prevent premature extrusion of the tubes from the patient, so there's a more predictable time frame.
In vitro results are incredibly promising. We look forward to animal studies through an animal model that's already established, and we hope to be able to consider a human clinical trial in the not too distant future thereafter.
For me, it was very important to work on this project and try to find a better solution available for parents who definitely desire a more reliable medical device implanted into their children's ears.